So I work at Google. I work on a team called Blink Interactions, which is basically scrolling animations input APIs that users can use to interact with the web. And Scope View Transitions is a new API that we're building. By the way, I don't usually bother with like slide transitions in my slide decks, but I figured if there was ever a talk that needed slide transitions, it was this one. So I'm going to start by just explaining what view transitions are, and this is going to be, I know some people in this room are already view transitions experts, and I apologize, this will be things you already know. But for those of you who may not be as familiar, we'll start with explaining what they are. So the web started as a document platform and it became an application platform. And when you're building a rich UI for a web application, you want to have fancy state transitions so that when the user is doing things in your app, you can animate between the old state and the new state, whether it's a navigation or adding or removing something from a list or what have you. And why is this good? Well, it looks nice, but it also improves usability because it's easier for the user to kind of follow along what's happening or what the side effect is of whatever it is they just clicked on. So that's great. And we've had CSS animations for a long time in the web. But doing everything through the Web Animations API is kind of hard. So you can certainly like put your new DOM into the DOM alongside your old DOM and set up the animations properly so that the old one was like fading out or sliding away and the new one is moving in. But you have to get a lot of things right. The crossfade, there's some subtle things that you have to do to make it look good. In order to position the new thing directly on top of the old thing, you have to kind of measure where it is and do geometry calculations. If you want things to pop out of their containers, let's say you're moving from one container to another, then it's literally like you're taking that DOM element and moving it out of that container. And then you potentially have to reapply all the styles that it was previously getting through that container. And then the other thing is you have this transition period where you have both the old DOM and the new DOM in the DOM at the same time. And you have to make sure that the user can't interact with the old DOM, like click on things. You have to kind of disable the interactivity. And there are ways to do this, like you can solve all these problems, but it's a lot of work. It's not ergonomic. So we wanted we wanted an API that makes this easier. So now this launched either last year or 2 years ago, I can't remember, but document.startViewTransition, you just call it and you give it a callback. And inside your callback, you update the DOM however you want. And it automatically sets up, and you declare like certain elements in your DOM that are supposed to be participating in the transition. And it will automatically set up like an animated transition between the old state and the new state. And this is not the talk where I go into like all of the different ways that you can use this as a web developer. There have been excellent talks already by Bramus and Jake Archibald about that I would highly recommend watching. But to go into a little bit of kind of behind the scenes, I started working on view transitions like 2 months ago, and it took me a good month to kind of wrap my head around how it actually works under the hood, because there's a lot going on. But basically, we create this pseudo element tree. So we create, during the transition, we have these special pseudo elements that are hanging off of the document element. And the root is kind of this view transition overlay that's on top of the whole page. And then for each of the elements in your real DOM that you've declared as participating in the transition with this view transition name CSS property, they will cause corresponding pseudo elements to get created in the pseudo element tree. So we have a group, we have a view transition group that represents like where that transition is going to happen. And then we have the view transition old, which is displaying the previous state of that participant, and the view transition new, which is displaying the new state. And then we set up styles, and we auto-generate kind of user agent styles for these things. So the group has keyframes that are taking you from the old size and position to the new size and position of the participant. And the VT old is fading out, and the VT new is fading in. But the developer can override these, so they can declare whatever styles they want for these special pseudo element selectors, and that gives you really powerful ways of like customizing how the transition looks. The other thing that's happening behind the scenes is we're using compositor magic to steal the pixels from one layer and transfer it to another layer. So if your real DOM has some content, it's producing some rendered output through layout, style, paint, compositing, and all that. We capture that in a compositing layer, and then we've set up the view transition pseudo tree, and these are all other elements that are creating their own layers. And the transition has 3 phases. So we start with the capture phase, and then the second phase is running the callback that the developer supplied, and the third phase is actually running the animation. And during the capture phase, the first compositor frame that we submit after you requested a view transition is simply capturing the pixels from the live element and transferring them into the layer for the view transition old pseudo element, and taking a screenshot of that. So we essentially save the texture for that element's layer in the view transition old pseudo element. So we'll continue rendering that screenshot. And then when we run the callback phase, this is where the web developer gets to muck with the DOM however they want. So they'll change it to something else. And then the third phase is the animate. And for that, we do the same pixel stealing mechanism to transfer the render output from the live element into the view transition new pseudo element. And these pseudo elements, remember, they're not necessarily in the same place or have the same draw properties applied to them as the live element. So this lets us have essentially views of that element that we can style differently and animate all of the transition effects between the old and the new state. So there's a bunch of compositor magic behind the scenes to make that possible. The other piece of this is that we have to pause the rendering while the callback is running. So remember the 3 phases. There's capture, callback, animate. Capture is taking the screenshot. Callback is running the callback, but while we're running the callback, and these callbacks can be asynchronous too, because they return promises. So your callback could return a promise, and then you're still in the running the callback phase until that promise actually resolves. So that could be multiple, vsync opportunities where we would potentially render intermediate content if we didn't pause the rendering. But while we're in this stage, we don't actually want the user to see the side effects of those DOM changes. So we essentially say, don't render any frames while the callback is running. And then when we're ready to animate, then we resume painting, basically. So that is how document view transitions work. So what about scoped? So scoped is, we launched document view transitions, and they work pretty well, but they have some problems. The problems mainly stem from the fact that it's a global concept. So you have one document, could have arbitrarily many components inside it, but you can only call start view transition on the document. And when we set up that pseudo tree for the special view transition pseudo elements, those are hanging off of the document element, the HTML element. So that's limiting, because for one thing, you can only run one transition at a time. As I mentioned, we have to pause the rendering and for the entire page. And this view transition overlay, the pseudo elements are kind of sitting on top of everything in the Z index. So that essentially means they're above what you can't tell them to paint behind other things that are in your DOM that are not participating in the transition. And the other limitation is that this view transition is position fixed, and it's sized to the viewport. So all of these transitions are essentially animating in viewport space, regardless of whatever kind of container properties the live DOM has inside it. This is not great because we want the web to be composable. So you're supposed to be able to have, independent components from different authors coexisting, potentially embedding each other, and not necessarily having to do all this coordination to manage this global singleton transition. We want them all to be able to run their own transitions and have it magically work together. So that's why we want Scope View Transition API. And the API is exactly the same, except you're calling it on element instead of document. So an arbitrary HTML element, subject to certain conditions about containment and so on. You can call start view transition on that element, and that becomes the scope for the transition. So the scope element is where the view transition pseudo tree for that transition is going to live. And this resolves the problems what you talked about. So now we can have transitions that are behind an overlay. They participate in the Z index because they're essentially painted along with the scope element. They're painted in the same order of the scope element relative to other elements outside of the scope. We can run multiple transitions at the same time, which we couldn't do before. We can run transitions inside of other transitions, which we couldn't do before, at least not in a way where they were not aware of each other. And finally, the transition will be affected by ancestor draw properties above the level of the scope element. So if your scope is inside a container that is moving or applying a clip or something like that, then the transition is also affected by those properties. And finally, the performance isolation. So since we have to pause the rendering for the transition, we would previously pause the rendering for the whole page. Now we can pause the rendering just for the scope element, and everything outside can continue to run. So those are the benefits. And how does it look under the hood? So we have this view transition object that used to be a singleton, but we've broken the assumption that there's only one view transition per document. So the view transition is now owned by the scope element and responsible for creating and managing these pseudo elements that are attached to the scope element and looking for tagged elements inside the scope element to participate in the transition. So we're reusing a lot of the same machinery, but we're just generalizing it a little bit to apply in scopes. So, and the implementation is partially working, and I'm going to show you the things that do work without showing you any of the things that don't work. See if I can share this tab. I built a little demo here so we can see. This is just a basic document transition. So I'm going to call document.startTransition, and I've tagged this blue box with view transition name. So that means it's going to be a participant in the transition. And inside the callback, I'm just changing the color and offset. So it's moving across the screen and becoming a different color. And so that works great. And but what if I have an overlay? So now there's a thing on top of it in the Z index. And if I do the same transition, it actually pops out above the overlay because the view transition overlay is on top of everything else in the page. And the workaround for this in the past was to make the overlay also a view transition participant, but that isn't necessarily what you actually want. What you want is to say a scope transition. So now with the scoped box, I'm going to call start view transition on the scope element, which is the orange box here. And I still have the same transition participant, but now it runs behind the overlay. So that solves one. And the other interesting thing you can do is maybe I'm inside a scroller. And so there's a container of the scope that is changing its position and applying a clip. So let's run the same thing as a document transition. And it gets a little weird because, for one thing, the participant pops out of the scope. So it's not at all what you want, and it's not affected by the clip of the scroller. So you see it sometimes appearing above the scroller itself. And if we enable the scope transition and do the same thing, now it's fully contained in the scope. And the last thing we can test is if we run two transitions at the same time. So if maybe I run a transition on that overlay, and at the same time, I run a transition on the scope, and they run at the same time. And there's a bug here, by the way, which I only realized yesterday. It's kind of subtle. As soon as any transition finishes, the other gets skipped. So there's a little bit of a jump. If I'm like near the end of this one and then I start this one and then the overlay finishes and then the transition jumps. So I got to fix that, but that's just a bug in the code. So there's probably
That was big.
Yeah, so there's maybe another quarter or two of work to get this production ready, but those are kind of the basics of what we have so far. And that's in Chrome Dev Channel with experimental web platform features enabled in About Flags. There are some things we haven't decided yet. For one thing, the search for tagged elements is still global, but obviously we want, when you call, when you start a transition on a scope, we want to only look for tagged elements inside that scope. So if I do start transition on scope 1, it's going to look for anything with a view transition name underneath scope 1. So it's going to find foo in the bar. But then what if I call start view transition on scope 2? That's also going to find the bar element at the bottom. So that's a problem. You can't have the same element participating in two transitions at the same time. And so what do we do there? Well, I think the easiest thing is to skip whatever transition was already in progress if we detect a participant collision. Because you can set things up so that they're picking out different elements, like the scope 1 transition only picks out foo and the scope 2 transition only picks out bar. It's a little tricky to set up. You have to be careful about how you declare these things. And the other idea, to make this a little bit easier for people, there was a proposal to introduce a new CSS property that would essentially establish a scope boundary for the tag search. So now if I'm declaring that this scope 2 is going to be its own scope, then when I start the transition on scope 1, it sees foo, but it doesn't see bar. So it's kind of a blocker for the tag search, like don't keep searching into this subtree because I'm going to use that for a different transition. I'm not sure if we need this or not, but it might be useful depending on how often developers run into this kind of foot gun. The other question is, what happens if you have tagged the scope element itself? Does that apply to, if I've tagged scope 2 with Baz, does that make it a participant in the transition on scope 2, or is it making it a participant on the outer transition of scope 1? And I'm not sure what the best answer to that is. On the one hand, if we want to be consistent with the way that document transitions work, by default, the root element is a participant in the document transition. So the user agent styles say that the HTML element, it's the root of everything else. By default, it has a view transition name, so it becomes a participant in your document transition. So if we adopt the same strategy here, then Baz would be a participant in the scope 2 transition. The weird thing is that the pseudo tree for scope 2 is inside the client area for scope 2, so it's inside the borders and so on. But if scope 2 is going to be a participant, then normally that would include the borders that we'd want to capture as part of the content for the view transition old and new pseudo elements. So I don't know. I'm tempted to say you should just not even do that. And if you want your participant, it should be a child or a descendant of the scope element. And that would simplify things a little bit. The other question is what to do if a scope gets resized during the transition. So document transitions right now, if you like resize the window, it just skips the whole transition. So because we don't know how to handle that, and this is it's tricky because of the pausing the rendering. So when we're running the callback, we pause the rendering. But if we want to pause the rendering only in a certain subset of the page, we want to make assumptions that that page, that scope size is not going to change. Because how can you pause the rendering and then have the size change in a way that affects content surrounding it that might potentially have to be reflowed? So now you're seeing some of the side effects of the resize, but not all of them. And that gets a little bit tricky to think about. So for now, I think resizing the scope is going to skip the transition. But if there's a need for us to handle that better, there might be other ways that we could do that. And then the last thing to think about is nesting. So View Transitions already had this feature called nesting of the View Transition group pseudo elements. And this is useful if you want to style them in ways that one of them clips the other. Like if you're rearranging items in a list and you want the list container to be a transition participant, but you want the items to also be participating, and you want the views of those items during the transition to be clipped by the container, then you want to nest these groups. And the API that we have, that we've recently launched already for this, before scoped view transitions became like a thing, is that you can declare a CSS property called view transition group on the element, not to be confused with the view transition group pseudo element that is in the view transition pseudo tree. But this basically says, hey, when you generate these view transition group pseudo elements, bar should be nested inside of foo. And so that's great. I think we've shipped that. But now we're launching scoped view transitions, and we're thinking about how do these two different features relate to each other. And if we have scoped view transitions, do we actually need nested view transitions, or can we kind of re-express nested view transitions on top of scoped view transitions? Because maybe what we do instead of nesting the groups inside a single pseudo element tree is we have a separate pseudo element tree for the child element. And then it starts to look more like a scope transition, even though you're still calling start view transition only once, maybe on the document. But there's a proposal out there to kind of unify these two things. And we're still exploring what the consequences of that would look like. That's the end. Happy to hear thoughts, feedback, questions, comments.
Yeah. How is the adoption of this new API? And is it compared with the native sometime, like if a native view transitions, how is the comparison when it does via web?
I think, so it's only Chrome for now. So the other browsers haven't adopted it yet. So that's a bit of an impediment for web feature adoption. But I think part of the motivation for this feature was to achieve better parity with what's possible on native mobile platforms like Android and iOS.
And how is the performance comparison? Like, has there been anything?
How's the performance?
Yeah.
I'm not sure. I haven't looked at numbers for that. I think that there are some low-hanging fruit in the performance space to like do things more efficiently. We've initially built it and just tried to like do whatever we could to make it work. And
Okay.
there's some inefficiencies in the way that we handle injecting the styles in particular. I think there's a lot of redundant style computation happening that we could optimize.
Okay. Yep. Thanks. Sounds good.
Isn't Safari working in the space, running this?
I think so.
Safari,
checking
Safari
it.
did ship it.
Safari shipped it?
Yeah, the document transition.
Oh, okay. So it's just Firefox that doesn't have it.
And
And it is part of Interop 2025, so one hopes and expects that, in this calendar year, Firefox will get there.
But the thing in Interop 2025 is only same document view transitions, which is document authority view transition, and not cross document view transitions.
I think that's right, yeah.
So Safari has same document and cross-document support. We have same document, cross-document support. And Firefox is expected to land same document support this year because of intro.
Yeah, there's a function called element in CSS backgrounds.
Sorry, say again?
There's a function element in CSS backgrounds where I can pick an element and use it as an image in the background image, for instance. Does the code you're doing for this make an implementation of that simple or?
Sorry, I'm not sure I follow. You can declare an element background.
There's a background image, colon element, parenthesis, and I don't
ID
remember if
selector.
it's a selector.
I think it's an ID selector, yeah.
Oh, okay. I didn't know about that.
It's only supported by Firefox, I think.
Yeah.
Not this, but there was the working canvas. Some working canvas may make that easier. I think I realized while doing the work. So I think the answer is no, not directly.
I have a question. You said like, oh, we can't do two transitions on the same element, but if they're exclusive CSS properties or just transforms, you could stack them and combine them, right? But I guess you can work around by just making a nested element that does the other transition. And then my question is, maybe you already addressed it with the nesting, but can you guarantee that those transitions will start at exactly the same time? Because you go through these states, and one of the states has async stuff that might take longer than the one for the other transition. Can you still guarantee that they start at the same time, so that if you have like a row and a column and an element that does both, that they are in sync?
Yeah, that's a good question. I think we could, because there's a state machine that keeps track of what we're still waiting for, and we don't start the animation until we have the capture and we've run the callback and all that. So if we were building nested view transitions on top of scoped view transitions, we would just extend the logic for that state machine to wait for all of the transitions to be captured.
But until you have the nested stuff, that would not be possible.
Right. So if you just do a scoped view transition and then the developer starts another scoped view transition inside it, then those are kind of running asynchronously with no guarantees about relative timing.
You don't always want to start those together. Like it could be that you're starting an animation here and some totally unrelated
But
animation.
you want to have control, right? As a developer, you want to have control. You
Oh, yeah.
have control whether or not to
Yeah,
start.
right. I'm just saying it wouldn't,
No.
we wouldn't always want to start them.
No.
I think Alec?
So this is going to revolutionize the prolonged international nightmare of having little bits of JavaScript for unblurring images, right? When the high quality version loads. And it answers a bunch of questions about why my attempts to do that with the old transitions were such miserable failures. Are you looking also at kind of like using this as infrastructure for new features? Like it would be great if the platform had like an inline kind of, blur hash kind of thing that we could just sort of build on top of this.
An inline, what, sorry?
Blur hash? Like
Blur hash?
like some way for you to provide a low res image that we sort of provide in that kind of blurred out way.
Oh, okay.
And then like, it looks like the CSS would be super simple for customizing how the transition would actually work.
Oh, yeah, that's an interesting use case. I hadn't thought about that.
I think we want to extend this to CSS eventually, like where you have a declarative way of saying something like transition contents. And then whenever contents change for some definition of changing, go on a new transition instead of just changing it. Very cool.
Hi, my question is kind of related to Yale's question, actually. So I come from actually 3D game engine mobile background, so don't eat me live. But I've worked with, like low-level rendering loops where, you have animations and you can sort of prioritize them in the rendering loop. I guess I'm just sort of curious where in the rendering stack here you're sort of can implement these and have sort of that and if you can have sort of granularity on managing like animations.
Yeah, so you can use all of the standard CSS animation rules to style the transition elements. And so you can achieve a lot of effects that way.
Okay, you're not going any lower than that. I'm just curious.
Well, it's not like a compositor, right?
Are you wondering like what kinds of hardware acceleration can be utilized, or something different?
I guess like how close do you get to like manipulating the frame buffers, for example?
To
Like,
maximum
like,
performance?
Yeah, like having to have that granularity over, yeah, things like composite layer.
Okay. What would you say, Vlad?
This is 2 level up on the,
Is it-
before the frame
okay.
buffer, yeah. We haven't hit the viz yet, so
Glad
after.
you implemented a lot of that low level stuff, which is why I'm asking you.
I mean, the animations do happen in CSS space, so it's all CSS. Moving the graphics buffers and hoisting them around is a bit compositor stack. So we do try to optimize. Like the old state is a pixel readback of the buffer, but the new state is just moving where the paint would have gone to go instead into the pseudo element. So there's no extra screenshots or anything like that.
Zero copy, I mean.
Yeah.
And there's also some control of the timing would come up in that situation, which gets to the other question of how much you can control when the transition starts.
For timing, like start view transition returns the transition object, and it has a bunch of promises that are good sync points. So like there's a ready promise, which means that all the animations will start the next frame, but they haven't yet started. And that's a good hook to go in and say, I want to start my custom CSS animation at exactly the same time. So you would hook in there, but there's nothing like per frame low level.
If, as a web developer, if you want that, I think there have been web platform APIs for very low level graphics. And like Steve started with like today, this is how it was done. If you want full control, this was available. The problem is that it's not accessible, right? It's very difficult to do. And most folks don't want more lower level. They wanted more simplicity. So this was a way to say declaratively and easily just say, do a nice thing. So most folks don't want low level, it's just performant enough.
I see. Okay. Yeah, thanks guys for entertaining me. I didn't want to out myself as like a non-web person, but that's what I found is really interesting.
So I have one question, like if you tag an element with your transition name, does that force it to be a layer in?
Yes, it does.
Okay. So like
Yeah, it's a layer, and then we set up a special effect node to do the pixel stealing into the different layer.
So the pixel stealing, that's not actually a readback, right? It's just taking the layer's contents and putting.
It's not actually a what?
It's not actually a readback, right?
A re.
Like
a copy output request.
Moving a render pass.
Oh yeah, just moving it, right?
I was gonna ask, what other options besides skipping the transition are viable when the container owner changes size or gets manipulated? Because you mentioned that as an option, and then like, could we just stop the effects of its resize from happening completely? Like you mentioned, it'd be weird if we didn't visually resize it, but we did reflow other things around it. But can we just like pause all of those kinds of manipulations and let the transition?
I think it wouldn't be too hard to allow a resize during the animation phase.
Mm-hmm.
The trickier part is if the callback resizes.
Yeah.
Because then how do you know where to pause the rendering and where to unpause the rendering?
Right. Okay.
I have more questions about low level. I will out myself as a non-web person. In the context of Viz, does a view transition just look like CSS is animating, or is there like if we look at a compositor frame while a view transition is happening, can we like determine that a view transition is actually happening?
Yeah, so the CSS animations just look like CSS animations, but then there is a special directive to Viz that says that you're reusing the render pass from a different layer. And Vlad is the expert here, so he will correct me if I've said that wrong.
Is that like a reference filter?
During the animation, we append a different quad. It's a shared element quad or something.
Oh, okay.
And in Viz, there's a surface animation manager which replaces that quad with either a different render pass or with a texture if we captured it previously. So and this happens like before surface aggregation and onward. So it's at the very beginnings of this is when we do that, and then everything after that just looks like a regular render pass.
Okay. So I like after surface segregation, it's
Even before like input to surface aggregation already looks like a regular.
gotcha. Okay.
Yeah.
Cool. Thank you.
Yeah, so during the capture phase, we're doing this render pass transfer in the compositor frame. There's a special directive that says use the render pass from the real DOM element. And then once we've saved the texture, then we've update the way that the view transition old element renders to just reuse that saved texture. And then the VT new uses the same mechanism, except that VT new is a live view. So if you're changing the live DOM during the transition, that gets reflected in the way that the view transition new element renders.
Mm-hmm. And then just one more question. The saving of the texture of the VT old is sometimes a texture, sometimes just reusing the old render pass.
No, the saving is always a texture.
It's always okay.
Yeah, that can maybe be optimized in the future, but right now it's always a texture.
Okay, cool. Thank you.
So kind of along those lines, if you had something that was moving like an animated GIF or a video, does that mean it's frozen while it's transitioning?
It's frozen in the old state, but it's not frozen in the new state. So you can get interesting ghosting effects where you see both of them together.
But you can work around that.
Yeah.
Like with CSS, you can say the VT old display none, and then the VT new you don't animate. You just get like the full opacity of one, and then you only see the new snapshot going on. For example, like a video player expanding is totally possible with this, and you see the video keeps on playing as it transitions. Steve, there is also a question in the chat. Somebody asked.
What is the behavior when window itself is resizing? That skips the transition currently. So the document transitions, they only work if the size of the viewport is constant. And I think there are some special hacks to handle the browser controls on Android coming in and out, so that we do allow that. But on desktop, if you resize the window, the whole transition skips to the end.
If somebody wants to check out a bunch of demos, view-transitions.chrome.dev, and there's a bunch of demos on there, both SPA, so same document, and cross document as well.